So we're going to do a flipped lesson today. So as you watch the video, I want you to follow along in your notes. Make sure that you're actually taking the notes. That will be for a grade. You can pause the video at any time. So if you need to catch up on what I was writing, or maybe if I'm moving too fast, you can pause it and write it down and then continue the video. So the other day we learned how to add integers, which are positive and negative numbers. And so today we are going to add rational numbers. So I first want you to complete the warm-up. You're going to do this on your own, so feel free to pause the video. And then we are going to continue on with the notes. So pause the video now so you can complete the warm-up. I'm going to go over the skills practice because this is everything that we learned the other day in class, and it applies the rules in which you're going to see again today. So when we're finding the sum, we need to first ask ourselves, are they same sign or different sign? So these are the same sign. So we are going to add them like normal. So we're going to do 53 plus 23, and we get 76. And then we keep the sign of our other numbers, and both numbers were negative, so that has a negative in front of it. So our answer is negative 76. For number 2, you'll see that one is positive and one is negative. So we have different signs. So different signs mean that we subtract. So 78 minus 28, and we get 50. And we take the sign of our larger number. In this case, our larger number is 78, which is positive, so my answer is going to stay positive. Down here, it's an additive inverse, and so if you know what that is, you can quickly fill out what that equals, but if we forgot, we can see that they are two different signs, so we subtract them, so 53 minus 53, and that gives us 0, so our answer is 0. Remember, an additive inverse is always going to equal 0. So when we add a positive number plus its negative, it is always going to be 0. So just to recap on what we learned the other day, we learned that when our signs are the same, we add and we keep the sign. And then when our signs are different, we subtract and we take the sign of our larger number. So the same thing is going to apply today with our rational numbers. So when we have the same sign, we add them. And keep the sign. When we have two different signs, we are going to subtract and take the sign of our larger number. All right, so example 1, you'll see that we have fractions today. So remember, rational numbers are going to be positive or negative, and they're any number that can be written as a fraction or decimal. Well, any fraction can be written as a decimal, so it's written as a fraction. So we're going to find the sum of 3/5 plus negative 1/5. So first we need to ask ourselves, are they same sign or different sign? It looks like we have two different signs because one is positive and one is negative, so they're different. So are we going to add or subtract? When they're different, we subtract. So with fractions, we have to make sure that the denominator is the same. the denominator is the bottom number. So in this case, they're already the same. So we are going to keep our denominator as 5, and then we're going to subtract like normal. So 3 minus 1, that's going to give us 2. So 2 is our numerator. Our bigger number here is going to be our 3/5. And so that means that our answer is positive. So our answer is going to be positive. And our answer was 2/5. So here you'll see that our denominators are different. We have a 3 and we have a 6. Before we can do anything, we have to change our denominators to be the same thing. So we're looking for least common multiple. So we're going to look for the least common multiple, which means that we need to see what can we turn this 3 in or multiply this fraction by to give us a denominator of 6. So we got lucky because 3, when we multiply it by 2, that gives us 6. So we first need to rewrite our fractions so that way they have the same denominator. If they didn't have, if 3 didn't go into 6, then we would need to find a number to multiply both fractions by. So whatever we multiply the bottom by, we also have to multiply the top of our fraction by. So since we're multiplying 2 times 3 to give us that denominator of 6, so that way both our denominators are the same, we also have to multiply the 8 times 2, which will give us 16. And then we keep our negative in front of it. And then since the other one we didn't have to change it, we'll just keep the numerator as 5. So what do we do when the denominators are different? We need to find our least common multiple. Are they the same sign now or are they different? They're different. So that means that we have to subtract. So when we're subtracting with fractions, we're only looking at the top number because our denominators are now the same. So that means that our answer is going to have a denominator of 6. So our denominator just kind of follows us to our answer. So now we're going to subtract. So we take 16 minus 5. So that gives us 11. And then we take the sign of our larger number, and our larger number was 16, so that means that our answer is going to be negative. So our answer is negative. But this is an improper fraction. So now we have to change this to be a proper fraction. So we need to see how many times does 6 go into negative 11. So we're going to divide. We're going to do 6 divided by 11. 6 goes into 11 one time. So 1 times 6 gives us 6. We subtract those. So that gives us 5. So we have a remainder of 5, which means that our answer is 1 and 5/6. So this 1 here is now our whole number. And then our remainder is our numerator. What we divided by is our denominator. So our answer, oh, and I forgot, we have a negative answer. So it's negative 1 and 5/6 as my answer. All right, so we're going to do these ones together. So these have the same denominator, so I don't have to find my least common multiple. So I know that the signs here are the same, so I'm going to add them. So 1 plus 3 will give me 4. And then I keep my denominator the same, so we have 4 halves. And I keep my negative because both of my numbers were negative. Now, how many times does 2 go into 4? Well, 2 goes into 4 2 times, because 4 divided by 2 is 2. And then my answer was negative before, so my answer needs to say negative. Over here, we have a mixed number. We need to turn that into an improper fraction. So we multiply 8 times 1, and then we add 3 to it. So 8 times 1 is 8, plus 3 gives me 11. And then I keep my denominator. And my original fraction or mixed number was negative, so that stays negative. And then I need to add that to 3/4. You'll notice my denominators are different. So I need to multiply this fraction or this denominator to something that will give me 8. So I'm going to multiply that by 2 because 2 times 4 gives me 8. And then now I have, negative 11 over 8 plus 6 over 8. Different signs mean I subtract. So 11 minus 6 gives me 5. 11 was bigger, so my answer is negative. When we have a number that's a whole number, we're going to put that over 1. So right now we have 4 over 1 plus negative 7 over 2. So I'm going to multiply this by 2 on top and bottom to give me a denominator of 2. So 4 times 2 is 8. I have two different signs, so I subtract 8 minus 7. It's 1 over 2. And my bigger number was 8, and that was positive, so my answer stays positive. When we have decimals, decimals are a little bit easier than fractions, so we actually started with the harder stuff. But we're going to ask ourselves the same questions. Same sign or different sign? These are the same. So we are going to add. When you're adding and you're not using a calculator, which you totally can, but you need to make sure that you line up your decimals. So here I have 2 after the decimal, here I only have 1, so I'm going to fill that in with a 0. So I'm going to add them, bring down my decimal. So my answer is 2.25. Both of my numbers were negative, so my answer is going to be negative, so don't forget that negative sign. How can we check it? We can always use a number line to make sure that our sign is correct and our answer is reasonable. So for example, up here, I was at negative 0.75, and I'm adding a negative 1.5, so that means I have to go this direction, which is negative. So my answer is going further into the negatives. So I'm going to have you do the try-its on your own. So pause the video here to complete your try-its. And then now we're going to do the modeling in real life together. So the table shows an annual profit in millions of dollars of an online gaming company from 2013 to 2017. Positive numbers represent gains and negative numbers represent losses. Which statement describes the profit over the 5-year period? So we need to add these numbers together. So actually I'm going to have you do this one on your own, and we'll check that one in class. And then when you're done with that, I want you to answer the question at the bottom of your notes. You're making connections. How are adding integers similar to adding rational numbers, and how are they different?